Welcome to our video on unusual GCSE questions. These are questions that are not necessarily the most difficult ones, but they're a bit strange and they might catch you out if you've not seen anything like it before.
So this question is from the Edexcel Higher GCSE series, and it is from June 2018, paper 3, and it's question 19. So we're just going to pop the question up on the screen for you now to have a look at, and then you can pause the video.
Right.
Okay, do you want to start or shall I start?
Yeah, so this question is a bit strange because what they've done, which is what they often do to make a question more difficult, is they mix two topics together. What they've done here is put some algebra basically into a trigonometry question, and we've got to find the value of x, haven't we? And what they've told us is that tan E is equal to tan F. So it is a trigonometry question, but it turns out to be more about algebra in the end than trigonometry.
Okay. But you can see that they're both right angle triangles, so we're going to have to use our right angle trig rules.
Yeah.
And obviously this is tan, so we're going to have to use the...
Yeah, one of the main problems people have with trigonometry questions is they get the sine, cos or tan wrong, they choose the wrong one. But fortunately, this is actually like easy in the sense that they're only giving you, they've given you the two sides that they want. If they'd put something in here, it could have been even more tricky.
And then the question is literally saying tan as well. So
yeah.
So start. We know that tan of theta equals opposite over adjacent, so that's what we want to use. So
Okay.
we start with this triangle, then you know that tan, you can see your angle is E, your opposite is x, and your adjacent is 4x minus 1.
So basically you just take the formula that you know, look at the algebra, put it into the formula, don't worry too much about what's going to happen next at this point.
Yeah.
You just got to start, haven't you, really?
Yeah. And then you can do exactly the same thing for this triangle. So we've got tan of your angle, which is F, equals your opposite, which is 6x plus 5, all over 12x plus 31.
Right, so if you've got to that stage, you've made a good start, you've shown the person marking it that you know what tan does, is opposite over adjacent, and that you're not afraid of a bit of algebra. So now, the equations are equal to each other. Not the equations are equal to each other, the things are equal to each other in the equation. There's going to be lots of little mistakes and things in these videos as well. We're not going to...
No, it's
Yeah.
perfect. Do you want to go next?
Right, yeah, I'll go from here. So if that is equal to that, then we're going to put this equal to this. So we've got x over 4x minus 1 is equal to 6x plus 5 over 12x plus 31. And now we've just got to solve this equation. It looks like a difficult equation to solve, but it's not so bad. You just need to know a few facts. So if you've got a fraction equal to a fraction, the best way to sort that out is to cross multiply. Don't be tempted into thinking that you can simplify these as they are by crossing out x's or anything like that. You've got to be really careful and know what you're doing. So if I cross multiply these, what have we got? We've got x times by 12x plus 31 is equal to 6x plus 5 times by 4x minus 1.
And then just to mix up the colours, do you want to expand that side or expand this side?
Yep, go on then.
Go on.
Yeah. So 6x times 4x is 24x squared, 6x times minus 1, 5 times 4x, 5 times minus 1.
Cool.
Now then, big quadratic equation. How do you solve quadratic equations? Get everything onto one side, make it equal to 0. So what have we got?
So we're going to take it to that side because this is the bigger value of x squared.
So if I start with 0,
Yeah.
we say 24x squared minus 12x squared. It's 12x squared. Hope we're still in frame. Minus, so what have we got? Minus 20. We've got 20x minus 6x, 14x.
And then take away another 31x.
Right, so 14 minus 31. Do 31 minus 14 and flip the sign. Yeah. So
minus 17.
-17. And then -5.
Okay.
At this point, you want to check to see if these three numbers have all got a common factor that you can take out, but they don't. But it's worth checking, yeah. And at this point, we've got to solve this quadratic. Now, it's question 19, it's near the end of the paper, so expect it to be a little bit tricky. But I'd still have a go at factorising this personally, because 5, the only factors are 5 are 1 and 5. 12, you've got a few to choose from, but not loads, so let's have a go.
Should we start with 3 and 4?
Yeah, we'll start with 3 and 4 now. If I put 5 and 1, and we'll sort the signs out in a minute.
Yeah.
There's a good reason to start with 3 and 4, because if, I mean, it might not be 3 and 4, but to make 12, the numbers in here, you could have 12 and 1, 6 and 2, or 3 and 4. More often than not, it's going to be the numbers that are closer together. That's just what they do quite a lot. It's one of the reasons is it keeps this number from getting too big if the numbers are close together. So what have we got? We've got 4 and 15. That doesn't make 17. I can't make 17 out of that. If I put,
you can have the 4 here.
I have the 4 here. I'll make 20.
And then that's going to make 3.
And I would put your signs in last. So because it's -17, you want to make sure it wants to be -20 plus 3, doesn't it? Now, does the question say...
So it asks us to find x.
Asks us to find x. Now, a quadratic we know has 2 solutions. And it uses this trick, doesn't it? If you've got 2 things times together to make 0, one of those things has to be 0. That's the mathematical idea that's being used at this point. So to make this bracket 0, well, what does x need to be? It would be, do you know? And you see, the thing is, if you look at this and you think, oh, it's not obvious, particularly in the exam, if you're kind of under pressure, don't forget you can always just write that out, equal to 0, and then solve it. Don't forget that you can do that. So that means x is 5 over 3. Here, x is -1/4, isn't it? So x. Now we've got 2 solutions.
This one has to be the right one.
But why does that one have to be the right one? Why is that? Well, you look back, and it's all about the context of the question, isn't it? So we know that the height of this triangle here is x. Can the triangle have a height of -1/4? It can't, can it? So ideally, what you would do, you'd write something down, and you would say x must be positive because they want to see that you know there are 2 solutions, but you've rejected this one, and ideally,
this one.
And give the reason why. And that's it really. It's just a question of trigonometry and algebra. So, if you found that useful, tell your friends, tell us if you know us. Write in the comments any other questions that you've come across on papers that you'd like us to have a look at.
Yeah, that are a bit unusual or strange. They don't have to be like really hard grade 9 questions, just ones that don't like fit
just
the regular format.
a bit different. Yeah.
Yeah.
Okay, thanks for watching.
Thank you.